Hello, we are Team 4, and today we are excited to walk you through the full development cycle of our Smart Cup, a project that merges engineering, data analysis, safety-focused design, and much more. To begin, we need to understand the why behind this project, and our journey started with an extensive market research where we identified a significant gap in personal hydration industry. We found out that most consumers are interested in tracking their daily basis intake of water, but find current smart bottles either too expensive or too fragile. Furthermore, safety was a top priority for our target audience. This led us to select high resistance food grade polymer for the final design. And this material is not only BPA free and safe for consumption, but it also allows the product to remain lightweight and cost effective. By choosing this over stainless steel or glass, we ensure that our technology is accessible for everyone, either from athletes to office workers, without compromising on durability or portability.
Moving into the physical architecture, we designed the cup to be a cohesive system where every component has a purpose. And as you can see in our current build, which I'm going to place here, we utilize the whole bottle as the primary hub for data collection, and we mounted the ultrasonic sensor, the DHT11, the temperature sensor directly onto it, and this is purely a strategic placement, and we are currently using tape and an external mounting approach for this functional stage, but this does not mean that we intend to utilize this type of method in case we wanted to, I don't know, externalize it, market it, whatever. Because if that was the case, if we wanted to market it, we will try to implement an internal waterproof housing for the cables and the sensors and the Arduino. And this setup would allow us to confirm that our sensors can coexist in a small space without any interference, ensuring a reliable reading every time the user decides to check their cup, because in the end, that's what it is for, isn't it? It's an intelligent cup, so that's why the user bought it. So, yeah.
Now let's talk about the brains of the project. The digital process is what transforms a simple bottle into a smart device. The system operates on a continuous loop of inputs, processing, and outputs. The Arduino will receive two main data streams: the pulses from the ultrasonic sensor and the data from the DHT11. We developed a custom script that filters this raw data. For instance, the code will not just measure the distance, but using the mathematical formula of the cylinder volume, we will be able to convert such distance into exact milliliters, subtracting the empty space from the total volume, since the ultrasonic sensor is placed on the top. We also programmed a safety logic for the DHT11. If there's an issue with the sensor, the display will be able to show that there's an issue, such that the DHT11 does not communicate false data or no data.
Finally, we have our functional prototype. For this stage, we use our protoboard to manage the electrical connections, which allowed us to iterate and fix wiring issues quickly. The build successfully validated our proof of concept. The LCD correctly showed us the volume and temperature without any lag. From an economic standpoint, our analysis was very promising. The total production costed a unit range between $25 to $46. When you compare this to the high-end smart bottles of the market and retail, they are almost over $80. And our project proved that smart hydration can be both affordable and high-tech. Our next phase will be to shrink the electronics package into a custom board, but as for today, we have proven that the engineering behind the Smart Cup is fully functional and ready to go to the next level. Thank you for your time and for joining this presentation.